DNA added in the genetic codes, which is in a mutation. So, based on that timeline up there, when did life supposedly begin on the lower?
20 million years ago. I mean,
life began.
Oh, 3 billion.
3 billion. Now that is a lot more than just 6,000 years ago, which according to the Bible, everything began. So, which one's right? What I want us to look at is how life supposedly began. So, according to evolution, the Earth was formed about 4.6 billion years ago. It's like 4.54. And it was kind of a molten mass, and then it slowly cooled, and then water collected in the atmosphere, and it was raining on the rocks for a while, and then eventually it turned into kind of inorganic soup at first, and through a series of chemicals and what they think might have been like shock of electricity, we got our first living cell. So that was about 3 billion years ago. Now, in order to get a single cell living organism into a human, I just think you need a little bit of information. A little bit. You need to gain quite a bit in order to do that. Is it why? Hey, we're talking about evolution today. You didn't miss much. Just started a little bit ago. So, in order to get from a single cell living organism to a human, you need to gain a lot of information. And we have never observed that. So, anyone want to read 1.2? Any extra packets around there?
It doesn't say 1.2. It just says 2.
I have a 1.2. No one has a 1.2?
No.
Seth, will you read 1.2 out of the packet?
Yeah. The ratio. Wait, when?
Go ahead, Seth.
Now? Okay. The ratio of beneficial mutations to neutral and harmful mutations is outstanding. There are far more neutral and harmful mutations than beneficial mutations.
Okay, so we know what a mutation is. It's basically just a change in the DNA of something. Some are quite obvious, like if you see a two-headed turtle or something, it's like, oh, that's a mutated turtle, something like that. What? Oh, right. Thanks for bringing that up. So, what I mean in 1.2, for those of you who have it, the ratio of beneficial to neutral and harmful. A good mutation versus a bad mutation, basically. So give me an example of a bad mutation. Cancer's a bad mutation. That is not a good mutation. Any others?
Radiation.
Right? What if you're like born without one of your toes?
Right.
That wouldn't be good.
Well, that wouldn't be maybe too bad.
Well, it may make it a little bit harder to walk. Or if you look at an animal. If one animal, now this is an extreme mutation, I don't even know if this happened, but say a monkey was born without one of his feet. It'd be pretty hard for him to survive, right? He'd probably die pretty quickly in the survival of the fittest setting. We'll talk about that in a little bit. But, so basically, most mutations are bad for the animal, or neutral, they just don't really matter. Very few mutations are beneficial, and those beneficial mutations do not gain information into the genome. Or in other words, like, and we're not talking about it here, but bacterial evolution that's in there, we're just not talking about it today, is when, like, this is one that's constantly used as evidence for evolution. They say, well, bacteria becomes immune to different antibiotics and drugs and stuff, it becomes immune. Well, that's true. That's because certain blocking mechanisms on the bacteria are lost, so that the bacteria can't climb onto the so that the drug can't climb onto the bacteria and kill it. So you're losing things, and when you put that immune bacteria back into a population of non-immune bacteria, it's inferior, and it'll slowly die off. The regular is better. So 1.3. Anybody have 1.3? The iPads even have.
It just says 3. It doesn't say anything there.
Oh,
Yeah, it says A and then 1, 2, 3.
Okay, well, does someone want to read 3 then?
A 3. I'll read it.
Go ahead.
Beneficial mutations may become harmful in a different location or time for a species.
Right, pretty much what I just said about the bacterial ones. If you lose that locking mechanism and you become immune to the drug, that's good, but when you're back into a population with the regular bacteria, you're not as good. And the ratio of immune to regular slowly evens back out, and there's more regular than immune. So mutations do not support evolution, and that's basically the main mechanism for evolution. We need mutations in order to go forward. But all we can really observe is mutations putting species backwards, all right? And the few that we do see that are beneficial may become harmful in a different time or place. So next section is natural selection. Anyone want to read natural selection, the first section?
I'll read it.
Go ahead, Zach.
Using evolutionary criteria, the hierarchy found in the reverse is the reverse of that expected by evolution theory. Animals lower on the evolutionary scale were found to reproduce in greater numbers and were a whole more resistant to variations in the environment.
I forgot to cite this source. This is from Dr. Jerry Bergman, I think. Has anyone heard of him?
Nope.
He's a professor over at the Northwest Community College. He's done some creationist work. School having a creationist like that pretty closer here. So basically what he's saying is, so many mutations are passed along every generation, right?
Mm-hmm.
Like one child might be slightly different than the original. That's how evolution is supposed to work. Every generation they're a little bit different, and gradually it might even become a new species. But according to this, like insects, some insects might only live a week. But yet we are a ton more complex than some insects that only live a week. So in a month, or not a month, but maybe like 5 years, you should see a whole new animal, right? If a new generation comes along every week, you should see huge changes. We have found fossilized, we found like flies in amber that look exactly the way that, or no, it was ants, sorry. Ants in amber look exactly like they do today. And we're not sure how old that is.
Aren't they like bigger though?
Bigger?
Aren't some insects bigger than they are today though?
They may have been. That would have had a lot to do with how old they lived in the days before the flood. So that very well could be. Yeah, basically what he's saying is the lesser complex things tend to reproduce faster. Like mice even. They reproduce like crazy, but they all look the same. If a guy took a picture of a mouse in the 50s and you look at one today, they look the same. Humans, we're so complex, but we only reproduce maybe every 20 years. A human has to, maybe when he's around, or maybe 15, 16 for some people, and then they have a child and it goes, mutations and everything. So that's just something that doesn't really make sense about natural selection, is how the ones with that reproduce faster are less complex. B2, anybody? 1.2. Went too many times. Grace, you want to read that?
Sure. Survival after birth tends to mostly be the result of chance. In most cases, natural selection eliminates only the sick and the deformed.
Okay, so that's like saying if you have 3 eyes, for instance. Let's say you're born with 3 eyes and that's a mutation, and even then, natural selection's probably not gonna do too much to spread that around like it's supposed to. So basically, natural selection only gets rid of the sick and the deformed like it does. So natural selection just keeps a species healthy. It doesn't propel it farther along in an evolutionary time scale. Anyone want to read B 2.1? Mr. Cressman, you want to read that?
Yep. Almost all the traits that breeders breed for have nothing to do with survival, and thus nature would not select for them. We breed dogs for certain appearance traits, cows for milk traits, and chickens for egg traits.
Right. So that's one of those things that you see as evidence for evolution a lot. Like, why do we have so many different kinds of dogs? Why do we have all these different kinds of corn and everything like that? Well, first of all, breeders know that there's a lot of extra information in these animals. So you're not gaining any information when doing this, but you can't like breed chihuahuas back into a wolf. You've lost information. You can breed wolves all the way down to chihuahuas, but you can't go the other way, right? What this is saying is, natural selection tries to, like, this is a great one. It's not, I don't know if it's on here, but like pigs. Farmers are always trying to breed a bigger pig, right? What is going to last longer in the wild? A lean, fast pig, or one that a farmer breed to be big and fat and full of bacon? Which one's going to last longer?
A decent sized one.
Those wolves are going to, yeah, exactly. Those wolves are going to be all over the big one. It's going to be slower. It's probably going to taste a lot better. It's bigger. There's more meat. It's slower. It's heavier. That thing's not going to last long in the environment, but yet that's what we're breeding. Bigger pigs. So that's just an example of natural selection. Natural selection wouldn't choose that, therefore that can't be evidence for evolution. 2.2, everybody? Seth, go ahead.
Animal breeders have found that select traits are often lost if random breeding again occurs, or if breeding for other traits is done. Few, if any, permanent changes in the animal usually occur. Only the probability of certain traits appearing is altered.
Okay, that one I said earlier about the bacterial evolution. You put it back into a population of the normal bacteria, and the normal outnumbers and overpopulates, and before you know it, that immune one is pretty much gone. Alright, so that's just a good example of that. 3.1. Chrissy, you want to read that one?
Is it for selection?
Yep.
Okay. For selection to occur, a living organism must exist that is capable of successful reproducing and also of adjusting, assimilating, and processing food. Secondly, a stable supply of food must be available, which it can use to manufacture the various complex elements and also produce a chemical reaction necessary to obtain the energy needed and to ensure the organism survives.
Alright, so now let's go back to that single-celled organism. If it was made through a combination of random chance and chemicals, I mean, the first organism really couldn't have been made from natural selection because it's the first one, There's nothing before that for it to evolve from. So it would have to have all of those things that she just listed. It had to be able to ingest and reproduce and all those different things. Yeah, I'll tell you right now, I didn't start citing my sources until like section like F or something. So little of none of this is my own words, just copy pasted that I found from various creationist websites, internet sources, books, stuff like that. So sorry about that. If you want to look more into this stuff, just talk to me afterwards, and I can give you a couple things to places to look. But yeah, these first couple sections aren't cited. 3.2, anybody?
For selection to take place, even at the cellular level, a structure consisting of dozens of complex, interrelated, functioning organelles must first exist. Many complex subcellular structures must somehow spontaneously form in conditions much different from today, and then resist the push towards entropy. Most all would disintegrate, but evolutionists must assume that some did not. These few must also have had a means to prevent destruction by too rapid atrophy, and also, among other things, must be able to ingest, to breed, and also to effectively reproduce. Only when all of this has occurred could selection select the animal which survived best and produced more offspring.
Okay, I really liked in science class, I think it was last week or the week before, because we got a vocab sheet, and it had, on both sides were vocab words. We were going over the E's, so it had words like enzymes and stuff like that. Evolution.
Who do you have?
This is Lamb, so it's nice. But I thought that was funny. On one side of this vocab sheet, they had entropy, which that's like over time, everything goes towards disorder. That's the second law of thermodynamics. And then on the other side, it said biological evolution, which says pretty much the opposite, that over time all things get better. I thought that was funny. It was on the just on flip sides. One said things get worse over time. The other said things get better over time. Of course, when I asked the teacher about that, well, she said, biological evolution is just a change, and I'm not going to deny that. Organisms change, but I want to know is to what extent do they change, and is that really evidence of evolution? Okay, so where are we now? Section C, survival of the fittest. Anyone want to read section 1:1? Matt, you got that?
Yeah. Survival of the fittest is a tautology, or a needless repetition of an idea. How do we know who is the most fit? The ones that survive. That is circular reasoning and has no bearing on science.
Right. So basically, survival of the fittest, it's just a circle. The fit survive, the ones that survive are the fit. Well, not saying much. It's just natural selection and another name. It's just, except this is just circular reasoning. So 1.2, anybody? Seth?
A less deceiving way of saying survival of the fittest is survival of the luckiest.
Right. So if there's like a nest with like 3 birds' eggs in it, and a predator gets into the nest and eats 2 of the eggs, is that last one the most fit egg, or no, it's just the luckiest? And that's the way a lot of nature works. It really doesn't usually have much to do with it. In some cases it does, like maybe the slower deer are caught and stuff like that. For the most part, it's survival of the luckiest. So 2.1. Mr. Kressel, you got it.
If a whale swims up to a school of fish and swallows a large portion of them, the one that survived are luckier than the first fish that are eaten, not more fit.
Pretty much another example. I can read 2.2. If you spray a nest of bees with poison and some escape, they are luckier than the bees that died, not more fit. Just a couple examples, it's just survival of the luckiest. So now we're going to section N.